Okay, 1.2 quadratic equations and applications. So first we have the zero factor property. So everyone's just going to refer to this as factoring. And what we need to know is that when we factor, if it's a quadratic, there will be two factors, not necessarily unique. We set each equal to 0, and those are the two solutions to the quadratic equation. Then we have, if the leading coefficient is not 1, we can try and divide by the leading coefficient to make it 1. If we end up with a fraction or something like that, then, maybe that's not advantageous. So we apply what's called the zero factor property, AC method. Go off to the side, label A, label C, multiply A and C together. Then B needs to be written as the sum of two factors of A times C. So our B is 13. Two factors of 30 that add to 13 are 10 and 3. So we split those up. The next part is called factoring by grouping. So we look at this group and factor out the GCF. Look at this group, factor out the GCF. And a helpful hint is the parentheses will have the same binomial. Therefore, we can factor that out. And so on this one, that factors as x plus 5 times 2x plus 3. Set each factor equal to 0 and solve. The square root property simply says that if we have a perfect square on one side by itself, we can square root both sides. Something to remember is, since we're representing a variable, when you square root a real number, there is a positive and a negative root. So let's take a look at this example. We've got x plus 5, the quantity squared, which is a perfect square, but then we're subtracting 10 on the left. So to get the perfect square on one side by itself, add 10 to both sides. Now we can square root. And so remember, when you square root, since that represents a variable value, we have plus or minus. Get x on one side by itself, and that's the square root property. Then we've got completing the square. Now let's start by the assumption that the leading coefficient is 1. If it's not, you divide everything by a, and then the leading coefficient is 1. So we've already done that part. Now we've got x squared plus bx plus c. We're going to move the constant to the other side, and then we're going to add a value to both sides to make the left side a perfect square. That value is b over 2, the quantity squared. Add it to the left and the right. So that's called completing the square. Let's take a look at an example. So if I've got x squared plus 10x minus 14, add the 14 to the other side. Then b over 2 is 5, since b is 10. And then if you square that, you get 25. So 25 is the number that we add to both sides. So we're going to add it to the left, add it to the right. So on the right, we'll have 39. And on the left, x squared plus 10x plus 25 factors into x plus 5, the quantity squared. So that is why we chose to add 25 to both sides of that equation. Then we apply the square root technique. So square root both sides. Square root's going to cancel out the quantity squared. So on the left, we'll have x plus 5. On the right, we'll have plus or minus root 39. Isolate x to get the answer. Last, we have the quadratic formula. Here is the quadratic formula. And then just note that if b squared minus 4ac is greater than or equal to 0, then x is a real number, which is what we're going to cover in this section. So an example is 3x squared minus x minus 5 equals 0. A is 3, b is negative 1, and c is negative 5. So then carefully substitute a, b, and c into the quadratic formula. Simplify one step at a time. It's tedious. Pay attention to detail. and then you've got x solved by itself. Then we've got applications of quadratic equations. So the first application is the area of a rectangle. So area is length times width. So our example is we have an area of 6,240 square yards. The width is 68 less than the length. Let's find the dimensions. So we start with A equals LW and substitute based on the information given. So A was given as 6,240. We are told that width is 68 less than length. So width is length minus 68. And we're going to substitute that for W. Now we've got a quadratic equation once we combine like terms. So L squared minus 68L minus 6,240. And I'm out of room on the iPad page, but use the previous techniques discussed to solve that, and we'll get 120 for L. Now we can use that value of 120 to find W, since W is L minus 68, and that gives us 52 for W. Multiply 120 times 52, and you get back to the area of 6,240 square yards. The next application is the Pythagorean theorem. So if you have a right triangle, the Pythagorean theorem states that the sum of the square of each side is equal to the square of the hypotenuse, or a squared plus b squared equals c squared. So in this example, it says that one leg of a right triangle is 2 less than the hypotenuse and the other leg is 4 centimeters. Find the lengths of the side. So we need to identify A as x minus 2, B is 4, and C is x. Start with a squared plus b squared equals c squared. Substitute for a, b, and c. Now, at first, we've got an x squared. It looks like we have a quadratic equation. We get lucky on this because when we subtract out x squared, we end up with a linear equation. That linear equation is solving for x, which represents c. And so we get x equals 5. So the hypotenuse is 5. The leg that is 2 less than that is 3. And the other leg was already given as 4. So that's just your basic 3, 4, 5 right triangle. Then we've got projectile motion. So this is a projectile motion function. This gives us the height with respect to time. So t is time, s of t is height, v0 is initial velocity, and that is given in the problem. So we've just got a placeholder here. The variables are time and height. So time is the input variable, the independent variable. Height is the dependent variable. And then s of 0, so when you plug in and when you substitute 0 for t, that's your initial height. And then we are going to use the gravitational constant of negative 32 feet per second squared. So that means the leading coefficient of this function is always negative 16. So in this example, we say find the height when t equals 1, given an initial velocity of 30 and an initial height of 4. So we take the generic equation, g over 2 is negative 16, v0 is 30, and h0 is 4. Now this is asking us to find height, so we need to find s when t equals 1. So all that means is substitute t equals 1. And then we output 18 feet. We could also find the time given a certain height for the projectile. So this example says find the time when the projectile reaches 36 feet if v0 is 48 and s of 0 is 0. So that'd be the object is launched from the ground. So s of t would be negative 16t squared plus 48t. So technically we have an initial height of 0 there. Then we are asked to solve for t. So t is the variable we are going to solve for, and we know the value for height is 36. So we're going to substitute out s for 36. So now we have a quadratic equation. 0 equals negative 16t squared plus 48t minus 36. Then use any of the techniques that we learned earlier to solve for t. And when you do that, probably the quadratic formula you get t equals 1.5, and this just happens to be the maximum height of this function. So that kind of will lead us into quadratic functions here shortly.